All right. So in this video, I'll be discussing how to create a highly available infrastructure on AWS. And to start, I'm going to give you guys a quick overview of what high availability actually is. So the definition for high availability is the ability of a system to operate continuously without failing for a designated period of time. This means that your web servers, your app servers, and your database servers are always running no matter the circumstance. High availability ensures that important systems stay up and running. Of course, your big tech companies want all of their apps to be available constantly, but there are some other more important systems that require high availability to guarantee the safety of its users. For example, autonomous vehicles, industrial and healthcare systems, and military controls all rely on high availability. In these use cases, people's lives depend on high availability. So before I go into the step-by-step overview within the AWS console, I'm going to give you folks a brief overview of the actual solution, just to get into your heads before we get into the details. So in a AWS highly available infrastructure, the availability zones will be accessed through a load balancer, which distributes the users so that not one availability zone will be overburdened. The servers within the availability zones will scale in or out based off the CPU utilization or other custom metrics and replace unhealthy instances using an auto scaling group. The databases will be highly available using a multi-availability zone and a read replica setup. And what I just mentioned about the databases is for relational databases. And non-relational databases in AWS are serverless, meaning that they're managed by AWS. They're highly available already, wonderful, and includes replication across multiple availability zones. Now, there may have been some words in that solution that you may not have heard of. And in this video, I expect a couple of things as prerequisites in order to understand what's actually happening in this video. So EC2 servers is something that you should definitely know before making a highly available infrastructure, as well as availability zones. Those are things that are kind of, you should go ahead and learn those things before you start to worry about a highly available infrastructure. And some of those other words that I mentioned, load balancers, auto scaling groups, I'm going to talk about those things. Don't worry about that. That's the whole point of this video. And we're going to start off by creating a highly available database infrastructure. Okay, to start off, we have to head over to the RDS service page, so Relational Database Service. Once you arrive at the screen, we're going to go straight into creating a database. All right, so once the create database page loads, this is what you'll see. So you can leave this as it is, standard create, and we'll go into engine options. And here you can pick the engine that you would like to use for your workload. I'm going to stick with MySQL. And here are the availability to kind of go through and pick a version that you want, but I'll stick with the default. We'll skip the templates section and head over to availability and durability. So this is the type of deployment that you're going to select for your database. And there's three options: single DB, multi-AZDB, and multi-AZDB cluster. Single DB just creates a single database in a single availability zone. Multi-AZ creates your primary database in an availability zone, and then a standby database in a separate availability zone. And that gives you kind of that multi-AZ, slightly highly available infrastructure. So that's where we're starting off with. So this is the one we will be selecting. But there's also this new option that AWS recently added, multi-AZ DB cluster. So let's read through it. Creates a DB cluster with the primary DB instance and two readable standby DB instances, with each DB instance in a different availability zone, provides high availability, data redundancy, and increases capacity to serve read workloads. So this one is a great option. It's extremely highly available. Databases in a bunch of different availability zones, read replicas in different availability zones. So it's a great option. It may not be the best option for your workload depending on how highly available you want it to be. For this video, since we won't be creating an insane infrastructure, we'll just be creating a few EC2 instances. I'm going to stick with this middle one. So here we have to give our database an identifier and fill out kind of this like access credentials. So I'm just going to put all the same stuff here. Definitely not what you want to do. Get my password stuff out of here. We don't need to see that. No, thank you. Okay. So yes, so just like fill those out with whatever you need. And here we're going to select the instance that you want, since the RDS actually runs on an EC2 server. For myself, I'm going to be using the free tier. So with these T2s, you can essentially select these are the smallest options that EC2 has to offer. But you guys probably know this, as I expect you guys to have some EC2 experience. And here you can select the type of storage you want. You can have some provisioned, a general purpose, or magnetic. I'm going to stick with general purpose for this video. Continuing through, here for storage auto scaling. You can also add that to your instance here. We will be checking that off for this video. And moving forward here. So now for connectivity, we have to tell RDS where it needs to be, right? So I'm just going to use our default VPC, and I'll just tell it to be in this default subnet group. Here you can, if you want it to be publicly accessible, we're going to stick with no. And now we should choose a security group. So I've already pre-created a security group. It's called Web Access. And that's the same security group that I'll be using for our EC2 instances. And all it does is allows inbound rules for HTTP, for SSH, and also for MySQL and Aurora databases on port 3306, I believe. Yes, 3306 is the port for this type of workload. So as we continue through, sure, you can stick with password authentication. And here's just the amount that's estimated. So click on create database. And now you just have to wait a few minutes for the database to be created. And then we'll get into how to create the read replica, which you guys have probably been expecting up to this point. And just realizing that we forgot to do one thing for this database instance, mostly on my end. I'm going to wait for this page to quickly load just to make some modifications. If you plan on deleting this database, then make sure you uncheck this enable delete protection. That will probably be in like extra configuration settings in that original page. I forgot to do so. But in my case, I will be deleting it. So I'm going to apply that modification. And I'll see you guys again shortly once it's all created. Okay, so now the database is available, and let's go take a look at it. So what I want to point you guys to is here we can see all the little networking and security. We go down here to replication. So this is our DB instance that's kind of standby. So just wanted to point you guys to that. I'm gonna head back here, and now we have to add our read replica. So you want to select your database, go to Actions, and Create Read Replica. I'm going to wait for it to load. Okay, great. So here we have our source, and now we have to come up with a new identifier. So I'm going to change things up a bit, add another number, and we're going to keep everything the same. So you can make changes to it. You can make your read replica slightly different than the source. I'm not going to do so. You can even create a multi-AZ deployment for the read replica as well. And here it automatically selects all the security groups that I configured previously. You can add some encryption to it, but only be encrypted if the master database is encrypted. So you could check these off, but if your master database is not encrypted, it'll not do anything. Continue down here. And this is unchecked as I unchecked the enable delete protection in my modification. And just create read replica. And now we have to wait a few minutes for it to launch as well, but it's essentially going to be the exact same thing, except you can only do reads from it. You can't write to it. So in any workload that you may have, if you have a bunch of reads and it starts slowing down your database and starts slowing down your workload, read replicas are a great fit. And once these load up, you'll have your highly available infrastructure. Your test 1, 2, 3, 4 here will be in one availability zone with its backup in a separate availability zone, or I would rather say standby. So its standby is in a separate availability zone if test 1, 2, 3, 4 ever does go down. And then there's read replicas. So if things start slowing down, then you can do reads only from your read replicas and do all writes to your primary database. And I'm going to move on to DynamoDB and the non-relational databases as these load up. But once they do load up, I mean, you'll be all set. So no need for me to dwindle here. And let's go to DynamoDB. All right, so now we're at the DynamoDB service page. So keep in mind that AWS's NoSQL database is serverless, meaning that it is managed by AWS, highly available, and includes replication across multiple availability zones. So basically, all the work is done for us, and all we have to do is create the table. So let's go ahead and do that. So click on Create Table, and just go through and fill this page out. So pretty simple. So our name will be NoSQL1. Let me spell that correctly, and then we can move on. And here you got to put in a partition key so you can kind of go through and sort everything. So you'll have like a super long NoSQL database. You can find it by your partition key. So we can do like last name, for example. And you can use a sort key too. So if there's a few people with the same last name, then we can put in first name as our sort of sort key. They're both going to be strings, correct? We're just going to keep the default settings, and you can just go ahead and create the table. And it's, I mean, really just as simple as that. Now you have your no AQL that I fixed that. Now you just got to wait for this to be created, and you have your highly available DynamoDB table. And next, we'll be moving on to auto scaling groups and load balancers for our computing infrastructure. Okay, so we're here on the EC2 service page, and let's actually talk about what auto scaling groups and load balancers actually are. So AWS says that an auto scaling group contains a collection of EC2 instances that are treated as a logical grouping for the purposes of automatic scaling and management. An auto scaling group also enables you to use Amazon EC2 auto scaling features such as health check replacements, and scaling policies. So basically, if you need more EC2 instances, more will be made. If you need less, some will be terminated. Scaling also occurs as a result of a policy that you can create. And also, when some instances are no longer healthy, they're going to be terminated as well. It is an amazing tool that allows your workload to function seamlessly no matter the circumstance, and also saves you time in the process. Now with the load balancer, AWS says that it serves as a single point of contact for clients. The load balancer distributes incoming application traffic across multiple targets, such as EC2 instances and multiple availability zones. This increases the availability of your application. And I don't really think much else needs to be said. Using a load balancer with an auto scaling group as a target, we can make our computing infrastructure highly available with EC2 instances in different availability zones and constant scaling ability. So after that, let's do it. So we're going to start off with the load balancers. So head over to the load balancers tab here, and let's go ahead and create a load balancer. Okay, so now once this page loads up, let's go in and select our load balancers. So depending on your workload, you will be needing a different type of load balancer. So application load balancers use these protocols: HTTP, HTTPS. Network load balancers uses TCP, UDP, and TLS. And gateway load balancer works with kind of more third-party applications. For this video, we'll be working with the application load balancer. So let's go ahead and create that. And let's give it a name. So I'm just going to give it LB1. It will be internet facing, and it will be using the IPv4 for its IP address. And so this part's pretty important. So you just select the VPC that you want it to be in, and then also where it's going to distribute the load to. So to be highly available, you need at least 2 of these, but we might as well go ahead and just use all 3. If I can actually click it, there we go. And let's select the security group. So I'm going to do the same one as I used before, web access. This is the most secure way to go about when doing these types of infrastructures, as they all share the same security group. So nothing else can kind of go in or out. Next, we have to select our target group. So where are we going? Not where, but what will we be distributing our load to? So it will be on port 80. So we'll be doing HTTP, and you have to create a target group, as I don't have any currently. And as that loads up, beautiful. So what are our target types? So we'll be doing this instances. So this will be kind of your EC2 instances. But there's also some other applications as well. It can be an IP address. It could be a Lambda function if you're creating a serverless kind of infrastructure, or another application load balancer. So let's give it a name, being really original here. It's going to be on HTTP port 80. That's the same VPC as before. And we'll be doing HTTP1. So this is for health checks. If you have a specific route you wanted to use, then go ahead and put that there. But I'll just keeping it as is, and we can continue. And here it's going to ask you to put like specific targets, like specific instances that you wanted to kind of point to. But at this point, we don't have that. We haven't created our auto scaling group. So we're going to leave it blank, and that's all right. This is all actually optional, so no worries there. And let's create the target group. Beautiful. So let's close this, and now we're back at our load balancer form. Let's refresh, and there's our target group. Beautiful. So we can continue on. We don't need any services, no extra tags. Here's our summary, and let's create the load balancer. And let's go over here to view it, and it's going to be provisioned. So give that a quick wait, but essentially now we have our load balancer created, and we're going to move on to our autoscaler group. All right, so now our load balancer is up and active, and let's go over to autoscaling groups. So we're pretty much there. Just creating your autoscaling group, and we'll be highly available. Be pretty cool. So let's create an autoscaling group. Give it a name, ASG1. You know, gotta stay creative. Gotta stay creative. And we're gonna have to create a launch template. And it seems like I already have one, but that's no biggie. So let's just create a new one for this video. All right, so let's call this one launch template 1. And I guess I have to give it a quick description. I'm just going to give it the same one, up to you guys to make it different, to actually have some organization, but who needs that? Just kidding. Make sure you actually do this. I'm just doing this for demo purposes. So now we have to, this is pretty much creating your EC2 instance, right? So this is what the auto scaling group is going to provision. And yeah, so whatever EC2 instance kind of works with your workload, go ahead and kind of fill this out. So I'm just going to walk through here and select the Amazon Linux one. This looks good, wonderful. Instance type. So I'm going to stick with the T2 micro one just for the free tier. And you're going to want to put in your key pair to access your your instance through SSH when necessary. I won't be doing that in this video, so I'm just gonna kind of skip over that. And let's see. So here, let's select a security group. I'm gonna stick with web access to kind of connect all these things now. So now our auto scaling group instances are gonna have web access. Our load balancer is gonna be using web access, and now our databases will be using web access. So continue down, and beautiful. Everything is filled out, hopefully. Awesome. And we can go back to our auto scaling group, hit refresh, and we have our launch template. This is all good. Let's continue. And now let's see where we're going to actually put these new configured or this new provisioned EC2 instances. So I'm going to select the same subnets and availability zones that we selected for the load balancer. And we can continue. Now, this is where we actually have to select the load balancer that the auto scaling group is kind of tied to. So we already have created one. So let's see, here's our target group with our application load balancer, LB1. We can continue down here. So if you want to enable health checks for your ELB, you can check it off of there. Beautiful. Let's continue. And now you can kind of create your desired capacity and your minimum capacity and your maximum capacity. So what does this mean? So minimum capacity makes sense. Like, what's the minimum amount of EC2 instances you want provisioned? 2. Let's just stick with 2. And what's the maximum? Let's do 5. And then desired capacity is the one that like the auto scaling group is going to attempt to kind of stick to. So around this amount, three EC2 instances. You can add a scaling policy. So if there's some sort of target that you want to stick to, you can kind of specify it. So for CPU utilization, and you want to stick to an average of 50%, then you can do that. And whenever there's over 50%, if there's like 90% CPU being used for your EC2 instances, the auto scaling is going to kick in and provision a few more EC2 instances, but we're going to stick to none for now. Let's continue here. Continue here. And no, I mean, you can add your tags here. Again, it's for organizational purposes. It is helpful if you're going to have a bunch of these kind of configured. So go ahead, maybe. And now we're at the review page. And here we go. We can just go and create an auto scaling group. And now it's going to start provisioning them. So if we head over to instances, and we refresh a couple of times, here we go. We have our desired state or a desired amount of EC2 instances now being provisioned. And there you go. So that's your highly available infrastructure. One thing I didn't mention with the auto scaling groups, as you guys know, with EC2 instances, you can add in user data. Same thing that you can do with the auto scaling group. And we were creating that when we were creating that launch template, right? So as we were creating that, we could have went into some of the extra options and put in user data that would be ran when these EC2 instances are provisioned. And there you go. So now you have this highly available infrastructure. Everything is able to communicate with each other, being within the security groups. And yeah, so hope you guys were able to go along with this video and create your own infrastructure. In the description, I'll link a blog that I've written that is tied directly to this video. And that gives you some more of just like a written down version of the steps. So you don't have to watch this video a bajillion times, and you can kind of just have a step through guide that can walk you through this quickly. Or if you're a visual guy, I'm a visual guy, this may be it for you. So thank you very much. Take care, guys.